We'll start with Jose Ignacio Alonso from UPM. We will talk about cooperative communications in 5G, use of amplify forward and decode forward nodes in FR1, less than 6 GHz and millimeter bands. Whenever you want, Jose Ignacio, the floor is yours.
My name is Jose Ignacio Alonso. I belong to the Microwave and Radar Research Group. This research group is a group of the Information Processing and Telecommunication Center of the UPM. I will talk about the cooperative communications in 5G and the use of relay node in this kind of communications. This is the agenda of my presentation. I will give a brief introduction of cooperative communication. I will explain the key element of this type of the communication, relay nodes. I will explain the industrial challenges that the use of the 5G or 6G communication has in the industry. I will present several use cases, and after that, I will present the research in my research group related to the relay node. We have several scenarios to deploy relay node in the 5G, in 6 5G gigahertz in any millimeter ways. And finally, I will give some conclusions. What is the cooperative communication? Cooperative communication are, also known as relaying technology or multi-hop relaying technology. They have several advantages. For example, improve the network functionalities and enable the possibility to design the heterogeneous network by integrating large cell. Play a key role in today communication wireless. They can increase the robustness of the transmission by assuring the quality of service, and they allow the path between the base station used to divide into hop or more hop. This is a method to improve the communication performance and achieve high capacity and high transmission speed. The key element of the cooperative communication are the relay node. The 3GPP has an important role in the standardization process of the relay node, and there are several relay nodes considered by the 3GPP. From our point of view, there are two kinds of relay mode. The more important are amplify and forward, or relay layer 1, and decode and forward, or relay relay layer 2. Both relay work in the in-band or out of band. What does mean in-band or out of band? Un relay in-band works in the same frequency. The input and the output frequency are the same. And the relay or out of band, the frequency, the input frequency and the output frequency are different. The relay node will have an important role in the integrations access the whole network. From our point of view, there are several industrial challenges to use this kind of component. For example, the use of, in the landscape of 5G communication, the relay node, for example, can help to solve mobile broadband connectivity problems. For example, to solve the growing demand for connectivity for entertainment in the smart house and smart building, and for example, for infrastructure autonomous car. The next slide shows the three use cases for the use of relay node. For example, in the transport scenarios, the relay node can be used in high-speed railways, urban bus fleets, or road transport. Or for example, in private car to increase the connectivity of the user performance. There are another use case, for example, 5G communication outdoor to indoor to improve the infrastructure for smart home service. For example, the use of the relay node in this use case improve the coverage inside the building. And there are another scenario where the use of relay node can be very interesting option. For example, in the infrastructure for autonomous car. Since 2018, in the framework of the project funding by the Spanish government for the Spanish Ministry of the Research and Innovation, the Microorganism Radar Group has been working in the developing of MIMO communication using relay technology. In this moment, the research group have developed a software-defined radio platform using USRP that tests the feasibility to use relay node in the cooperative communication. This platform is integrated by USRP, and this USRP has been used to emulate both the base station, the relay node, and the user equipment. Improve of the 50% of throughput and the reduction by half of the bit error rate for a given signal noise to ratio in the backhaul communication has been achieved. This is an example that we have done with using relay node. In this case, is from the communication from 5G network communication in 3.5 gigahertz band. We have developed an base station node. We have developed another platform to emulate the decoder and forward relay node. And finally, we have developed a platform to emulate the user equipment. In this platform, we have developed several algorithms to improve the connectivity between backhaul and access link. This algorithm, for example, are the decodification and the modulation of the signal and the channel characterization. This is the flowchart of the decoder and forward hardware implementation. This is, for example, we have measurement in the floor of the telecommunication school. In this case, this is emulate the base station. This is the transmit to backhaul link, and from this relay node to the user equipment. We have compared the difference between the transmission between the direct link between base station and user equipment, and the communication between base station, relay node, and user equipment. And this graph shows the advantage and the improve to use this relay node in this kind of communication. For example, this is a photograph of the demodulation del physical broadcast channels. This is another example that we have done. In this case, it's a communication in 60 gigahertz frequency from communication inside the building. We have developed an out-of-band decoder and forward protocol implementation, and this is an example of the measurement in the same scenario. And we have used equipment, commercial equipment of the Pasternak in this frequency, 60 gigahertz, and we have implemented some algorithm related with the phase noise cancellation. And finally, this is another relay node developed. This is the schematic of the relay node, the transmitter, and this is the receiver. This is a photograph of the equipment that we have developed. In this case, this relay node works in 26 gigahertz. We have made several measurements. In this case, it's a communication outdoor to outdoor. The communication is in frequency band 3.5 gigahertz, and in this case, it's 26 gigahertz. And the graph shows the improve of this kind, or the use of the relay node in this kind of the communication. And finally, I will with some conclusion. We have demonstrated the ability of use decode and forward relay node in 5G communication and 5G network. In 6 gigahertz and in millimeter band, 26 and 60 gigahertz. From our point of view, the relay node will be key element in the development of the future integrated access backhaul network for 5G beyond and 6G communication. What is the future research lines of the in our group? The future research line are related with the development of the commercial prototype of the decode and forward relay node outband that allow its operation in real time. And thank you for your attention.
Thank you, José Ignacio. I would like to ask you about your experience on application of these technologies in China. If you can give us any recommendation for other researchers that are willing to do some cooperation with China and technology transfer.
Well, I will speak about our experience about develop to relay node. We have presented this idea in a Spanish program to create a startup. It's the program Collider, funding by the Mobile European Capital. Our idea was selected between 400 proposals. We passed one phase, and in this phase, we have relation with several companies, and we'll try to convince the opportunity to create a startup or something related that. Finally, in this stage, our proposal don't pass, and we'll try to speak with another company that funding this idea. From our point of view, I think it's a good challenge, a good opportunity to work to develop a relay node, the decode and forward relay node in the prototype, because it's very difficult to find a commercial prototype of the relay node in the world. There's one or two companies that offer relay node, but a specific application. So I think the work in this relay node translate all acknowledgement to, for example, to implement an FPGA field programmable gate array will be opportunity to collaborate.
Okay, thank you. Thank you. I hope that you can get interesting collaborations from this project, and we hope to see you in future events telling us about these collaborations that have taken place. Thank you very much, José Ignacio. And now we go to the next, José Juan Arranz. He will present his talk about cooperative communications in 5G sorry, that was the previous one. Geometric documentation of infrastructures in civil engineering and architecture using LiDAR sensors and RGB sensors. So the floor is yours, Jose Juan.
Okay, thank you very much, Xavier. Good morning, everyone. My name is Jose Juan Arranz, professor of UPM in the School of Geomatics. My expertise is focused on geometric documentation using different kinds of sensors, from passive sensors like RGB cameras to active sensors like the latest LiDAR sensors. Also, these sensors can be installed over different kinds of platforms, from static tripods or airplanes, satellites, cars, and drones. As well, this sensor can be used in different types of projects and fields. The resolution depends on the sensor and the distance from the object that we want to map, from only 1 centimeter when the distance is very low, to several centimeters if the sensor are equipped over planes or satellites. This distance also is related to the accuracy of the data from 1 millimeter to several centimeters. The variety of the projects is from general mapping of the Earth, when we use sensors over planes and satellites in large projects, or in projects of lower dimensions but larger accuracies. For example, in projects of monitoring or mapping of infrastructures in civil engineer projects, architecture projects, archaeology, and so on. These sensors need additional data from other devices in order to georeference the data. There are several devices and methodologies to do this operation, but in general, we use GNSS receivers and inertial systems. With these devices, we can obtain position and orientation of the platform in their movement. And finally, the output data of the whole system can be of 2 different types. Raster data based on images. These images can register pixels with values in different parts of a spectrum, but generally we use RGB images and also values from near infrared. And vector data based on point clouds. These point clouds storage billions of points from the object. The mapping process is simple. We need to design an inertial project to know the boundaries of the project, the height of the plane, or the speed of the car, the needed accuracy or resolution, and so on. These parameters are decided previously at the office. Then the register process is automatic. Many of the projects need to georeference the data. This operation is made by users using GPS data or inertial data or coordinates of ground control points. And finally, we obtain data in different formats of the point clouds and images. But usually this information is not enough because we need the object identification in the output files or the vector definition by 3D lines or polygons. Then it's necessary to design algorithms to identify objects automatically. Some of these algorithms can need the user decision. Also, we could use artificial intelligence to define models in order to obtain the object definition. Using our experience in programming computer application and the treatment of geographic information of different sources, we propose some algorithms focused on the utility that can be given by geographic information in different fields of engineering and architecture. These algorithms allow us to automatic extraction of the information of interest in different projects and with different input data, images, point clouds, and so on. The output information can be stored in raster format or in vector format. In the first case, different algorithms have been developed for object recognition and to merge with other vector information, usually point cloud, to give 3 dimensions to the images. And in the second case, algorithms have been developed on point clouds that allowed objects to be identified and their 3-dimension reconstruction to be carried out. The output format can be BIM files, for example, to be used in Revit. Now, we are going to see several examples. We use these kind of algorithms that we we have developed and implemented in computer applications. The most current projects for documentation of raw assets inventory use equipment that incorporates laser scanning sensors, RGB cameras, inertial systems, and GPS. In addition, they carry out odometers and infrared cameras. This equipment is called mobile mapping systems. These systems are installed on vehicles traveling on the road without the need to cut off the traffic and at a speed of up to 100 kilometers per hour, collecting a dense point cloud and 1,000 of panoramic images. The information is massive, and the manual identification of elements is very difficult. Therefore, we have developed algorithms that allow automatically to identify pavement, horizontal and vertical signs, posters, other vehicles, tunnels, lighting elements, vegetation, containment elements, and so on. All of this is based on point clouds, but in addition, it's possible to extract certain objects by analyzing the 1,000 of images that are taken. Using these algorithms, the point cloud is segmented, giving different values to each point regarding of the object where was measured. The result is vector files based on lines and polygons with links to relational databases with certain characteristics extract, which are easily used by geographic information systems. Additionally, using the segmented point cloud and the panoramic images, we can extract vertical traffic signs. The identification is linked with a traffic database in order to give them an ID regarding of the type of the sign. As before, the same equipment mounted on vehicles on the track can be used in rail assets inventory projects. Characteristic objects of this type of projects are extracted, such as towers, catenaries, the rails, and so on. The result of this technology is also segmented point cloud and a vector file with 3D lines and polygons to use in CAD software or BIM files. But in some cases, it's not possible to use a vehicle traveling along the track. So sometimes laser scanning is used on a tripod or a backpack carried out by a person or drones with RGB cameras. For these kind of cases, the algorithm allows for mixing all the data from the air and data from the ground. And therefore, we can find a project where the data could have been captured from a mobile scanner, a static tripod scanner, and a drone flying over the area. Nowadays, there are LiDAR sensors that can be moved indoor without GPS signal to know their location. Then the position of the sensor is computed using SLAM algorithms. Therefore, the geometric documentation of interiors and exteriors of buildings has evolved drastically. Now it's possible to go through the different spaces with a scanner and obtain a dense point cloud with centimeter accuracy. But the problem now lies in transforming these millions of points into handy files with the planes of the building or the structure to define it. To do this, the developed algorithms allow to identify floors, ceilings, walls, columns, objects on the floor, objects hanging from the ceiling. For example, in this case, we scan a car parking with a remove the vehicles. The algorithm automatically identifies the structure of the space, that is walls, ceilings, pillars, but also identifies the vehicles in order to be removed in the next step to compute the correct parameters of area, volume, and so on. From this identification, it's possible to reconstruct the shape of the scan space using lines or planes from the most common applications such as AutoCAD or Revit. In fact, we can directly obtain the structure in BIM format. This format includes the structure in 3D volumetric objects which associate alphanumeric data. In the same line as the previous projects, we can collect data in a natural environment or in a park to inventory the different tree species. One of each element has identified. The taxometric data can be calculated, such as trunk diameter, height of the first branch, height of the tree, biomass, and so on. Another area of use of the massive mapping data will be the inventory of power lines. With LiDAR devices, it's possible to collect 3D data from the wires and the towers where they are supported. In the same way, the algorithms allow the reconstruction of the catenaries, identification of the towers, classifying them according to the shape, and so on. And finally, the projects where I start to develop my algorithms, general mapping purpose projects. In this case, aircraft are usually used due to the large extensions that are mapped, equipped with LiDAR and cameras, sometimes multispectral cameras. The developed algorithms allow the identification of background points for the computation of the digital terrain model and identification of other types of objects, such as buildings, vegetation, bridges, and so on. And in addition to general purpose to these projects, it could be used for cadastral updating. Well, in this slide, you can see some research projects and references and PhD projects of our university where we use our algorithms in order to demonstrate the use. Thank you very much for your attention.
Thank you, José Juan. I would like to ask you which kind of collaboration you think or you're interested in China, or which kind of companies or research institutes you think could be interested in doing some collaboration with you?
Okay. Well, geomatics is very transversal. And then a lot of fields of engineering use geometric data from civil engineer, but also if we want to document buildings or tunnels or some kind of objects. I think the use of LiDAR sensors is very useful, and we need to develop some algorithms in order to substitute that dense point clouds for more simple structures like planes, or for example, in a project documentation of piping, for example, we can use our algorithms or new algorithms from people in China in order to integrate our algorithms and our tools in other kind of projects. Then maybe civil engineer projects or architecture projects or something like this. But think about that geomatic is very transversal to a lot of engineer fields. Then I think we can integrate in different kind of projects, and we want to do better algorithms in order to substitute that dense point cloud to other kind of structure. For example, if you want to include 3D data in autonomous vehicles, for example, we need to develop new algorithms based on LiDAR data or images or something like that.
That's very interesting, because autonomous driving is really thriving in China. So it's interesting that you have also an application for that.
Okay.
Okay, so thank you very much for your presentation, José Juan. And now we move to the next field, which is sustainability, where Noemi Merayo, sorry, will present her work on water and wastewater treatment strategies to increase both water use and processes sustainability. The floor is yours, Noemi.
Thank you very much. Okay, my name is Noemi Merayo, and I'm gonna thank the organization to be here to talk about some treatment strategies to increase both the water use and the process sustainability, particularly in industrial processes. So I'm gonna start talking about water because everybody knows that water is very relevant. And one of the most important goals related to water is to achieve universal access to clean water. And I want to point a highlight in clean water because many people in the world is consuming contaminated water. So in order to achieve this universal access to clean water, sustainable management of these resources must be implemented. And this includes, among others, the reduction of consumption of contaminated water. So some treatment strategies should be applied both for urban and industrial wastewaters. In the right, we have a pyramid that shows several steps that can be applied in processes. I'm going to talk about industrial processes that goes from conservation, that is increase the efficiency of operations in the industry to avoid water leaks, to further steps like reuse, recycle, or reclaim the water in the processes in order to use the water again and with the goal of achieving zero effluent. If we achieve zero effluent in a process, it means that no wastewater was produced, so less contamination is put in water bodies. So we are contributing to the reduction of consumption of contaminated water. So water is a fundamental issue to achieve environmental sustainability, and in this case, particularly in the improvement of sustainability of industrial processes. So I'm going to show you some case studies I've been working on related with the implementation of strategies to improve the water use in industry and therefore to increase the sustainability of these processes. The first one is related to paper making industry. The objective here was the reduction of water consumption, and that was performed by studying some treatments applied to the wastewater of this industry to be reused as processed water again. So a combination of biological and membrane treatment was applied to achieve the quality of the water to be used in the process. We achieved more than 80% COD removal, more than 95% BOD removal, but also two main issues were identified. For instance, scaling compounds, its presence in the wastewater limited the recovery in the reverse osmosis treatment. So here is an economical limitation for the implementation of these solutions. And also a highly contaminated retentate is generated always when a reverse osmosis process is used. So we have also a technical limitation. Regarding the last one, advanced oxidation processes were studied to treat this concentrated stream, and phenton, photophenton, and titanium dioxide photocatalysis were applied in order to find out if this wastewater can be successfully managed in order to reduce the amount of contamination coming from these solutions. And these first, phenton and photophenton, achieved very good results, removing the contamination, and the TiO2 photocatalysis did not achieve so good results, but increased the biodegradability of the wastewater, allowing this water goes to a biological treatment that is cheaper and could work to reduce the contamination. Additionally, some strategies were performed to study how the combination of biological treatments and advanced oxidation processes can achieve better quality of the effluents treated in this industry. So the biological treatment was a membrane bioreactor, and it gets very good COD removals. It removes a very high amount of contamination from the water, And only when it is combined with ozone as a post-treatment, we increase the removal of COD above 90%. So the second case study is about food industry. In this case, the objective is to achieve the regeneration of a high-quality wastewater that is coming from bottles cleaning process. These bottles are used for use, and before the juice is put into the bottles, it must be cleaned and disinfected. So the quality of the water used in this process is very high. It comes from a reverse osmosis, and after the process, the water has this water and peracetic acid. As many legislations do not allow the use of water for food processing, the solution to use this water was to apply in a cooling tower in the industry. But before using this water in a cooling tower, hydrogen peroxide must be removed from the water to avoid the corrosion in this tower. So treatment with activated carbon was performed to remove this hydrogen peroxide, and different activated carbons and different conditions were tested to achieve this goal, and hydrogen peroxide was successfully removed. And the third case study is in chemical industry. I'm gonna show you 3 examples. The first one was an industrial wastewater containing 1,4-dioxane. 1,4-dioxane is a contaminant that is recalcitrant. We cannot remove from the water with biological treatments. So we have to go to more advanced treatments, like advanced oxidation processes. So we studied different advanced oxidation processes to remove this contaminant from the water, and we studied the degradation routes for this contaminant. And why? Because degradation routes allows us to know in which step of the oxidation process we obtain biodegradable compounds that would allow the combination of advanced oxidation processes with biological treatment. Biological treatment is desirable because it's cheaper and it's easier to implement and to operate. So this gonna facilitate the optimization of the process. Other in chemical industry wastewater was wastewater containing pharmaceuticals. In this case, the objective was to increase the biodegradability of this wastewater to send to a biological treatment. So ozone treatment was performed to increase the biodegradability. Around 20 to 30% COD removal was obtained using the ozone treatment. And one of the studies we want to perform was a comparison between the study of the efficiency of the treatment in the lab compared with the pilot plants. Because when we implement treatment at industrial scale, the steps or the common steps is to go first in the lab and then check in the pilot plant, finally implementing the industrial scale. But sometimes pilot plant could be avoided depending on what kind of wastewater and also what kind of equipment we have in the lab. So if we can avoid the pilot plant step, we reduce the cost of the entire process. Finally, the last wastewater is an industrial wastewater containing formaldehyde. Formaldehyde is a contaminant that is recalcitrant, so biodegradation is not the best option. And in this case, the objective was completely remove the formaldehyde, so this wastewater could be reused in the process inside the industry. So the first check was to use ozone to remove the formaldehyde, but only around 80% formaldehyde removal was achieved, and it requires the use of ozone plus hydrogen peroxide plus catalyzed, which is a very expensive solution. So other treatment, the treatment alternatives was aerobic biological treatment. That means biological treatment, but we need 6 months of acclimatization for the bacteria, and the industry didn't want that. So that was discharged. Advanced oxidation processes, but only gets 80% formaldehyde removal, and we need complete degradation of formaldehyde in order to reuse this water. So we want to another approach based on industrial symbiosis, and it is to use this wastewater containing formaldehyde and put it together with another wastewater containing nitric acid, that is another contaminant in the effluents of the industry, put it together to react and degrade the formaldehyde. So the wastewater, this treated wastewater could be used again in the process. So we optimized the reaction conditions, and we studied the amount of nitric acid and also the reaction time, the temperature, and the use of different accelerants. And at the optimum conditions, complete removal of formaldehyde and even complete removal of total organic carbon would be achieved with this reaction. Well, this is some of the case studies I've been working on. Now we are working on the treatment of wastewater, urban wastewater in rural areas, implementing treatments that are less expensive, but that allow the reuse of water, for example, for irrigation. And that's all. Thank you all for your attention.
Thank you, Noemi. I would like to ask you something similar to what I asked Jose Juan. Who do you think would be the main partners that you are looking for in China?
Mm-hmm. Well, I think it would be interesting to collaborate with other universities to develop, for example, we are working on different catalysts using for these advanced oxidation processes that are many times the solution for reclaim the water and to use again. So maybe the collaboration with other universities, other research groups could be very, very useful to determine what are the needs in China, because maybe are not exactly the same, and we can focus on that. And maybe also with, like here in Spain, with different industries that are interested in improve their sustainability regarding water and to increase their water use. So I think we are open to all the possibilities to work with universities or industries, even municipalities.
Okay. Okay, thank you very much. As I said, the sustainability and is one of the hot topics in China. So I think there will be certainly opportunities for that. Thank you very much for your presentation, Noemi.
Thank you.
Okay, now we move to our next speaker. We start now with the health part of the session. We will have two speakers in this part, and the first one is Olatz Albaina from the company I+Med. I don't know if I'm pronouncing well the name of the company in English. Sorry about that. And she will be presenting us their work on nanotechnology for medical devices and biomedical. Now it's fine.
Okay, so thank you very much for giving us this opportunity to join this event. Let me present myself. My name is Olatz Albaina. I work in I+Med or I+Med as project manager. This presentation is to present I+Med company, the work we develop here in the company, and the future actions of this company. So IMASMATE is a cooperative of scientists in the field of nanotechnology for controlled release and its biomedical application. It is located in Álava, the Basque Country, in the north of Spain. It was founded in 2013 in the research center of Lascarai in the Basque Country University. Then we moved to the Álava Technological Park, and it is foreseen to open the new premises of the International Biomedical Institute for Smart Nanohydrogels in 2024. IMASMATE, as a biomedical engineering company, is involved in the research, development, and manufacture of pharmaceutical products and medical devices with controlled release. But also, IMASMATE group integrates a unit of topical application, which is Unicare Bioscience, which is focused on advanced therapies, cosmeceuticals, and bioelectronic systems. According to our capacities, we are experts in developing hydrogels and nanohydrogels, coatings with antimicrobial and anti-inflammatory properties, and also nanocarriers to encapsulate drugs, and all of them with controlled release properties. So we develop, with this expertise, we develop our own product, and also we develop projects. We work on projects for third parties in order to produce medical devices and medicines, always under the quality system for medical devices, and also we have the authorization for the Spanish Agency of Drugs and Medical Devices. Just IMASMATE, to give you some numbers about our research capacity. Since we started, we have been working in 72 research projects. We have 36 researchers working on research. We have 4 patents and 12 regional, national, and international awards related to entrepreneurship and research. We have 2 services in IMASMATE. On the one hand, we have ADATMED medical devices, where we develop our own products, but also we have ADATMED technology, which it is a transversal technology where we develop customized biomedical and pharmaceutical solutions with high added value. So we adapt to a client's necessity. We consider ourselves as partner 360 degrees, since we have the capacity to assume all the phases of a project: technological development, patentability, certification, regulatory affairs, and quality assurance, manufacturing, industrial scale, analysis, and testing. And most of the research that we do is have these biomedical applications. And according to the ADATMED medical devices, as I have said, we develop our own products. Currently, we have 9 products on market. These are the injectables. We have 2 intra-articular injectables for osteoarthritic processes. The difference between these injectables depends on the quantity of the drugs, and also the duration of the medicine. Also, we have 2 intradermal fillers for dermatological purposes, 1 viscoelastic ophthalmic device for surgery, and we have 5 OTC products. We have 2 eye drops for dryness and irritation, 1 for humans, which is the drop, and the other for pets, which is body drop. And we have 2 topical liquid dressing for cold sores and also for mouth ulcers. According to the research that we do here in IMASMED, we work on projects, in regional projects, in national projects, and also in European projects. We cannot explain all the projects we are working, we are working on, but we are going to give you an example of 3 researches where we are coordinating. So, excuse me, NanoInject, it is a regional project. The purpose of this project is to develop nano-injectables to solve medical problems related to peroneal nerve and tissue regeneration. In the case of NanoMed project, it is to develop gold. It is also a regional project, and the purpose is to develop gold nanoparticles to improve biomedical therapies in skin, such as hypothermia, radiotherapy, and tissue regeneration. And in the case of Gamma-Regen, it is a national project. We are working together with a Taiwan company, Vedan Biotech, and the purpose of this project is to test or to carry out, all the tests necessary to use the gamma polyglutamic acid in order to develop, manufacture, and certify an eye lubricant drop. According to the future action of the company, it is to open our new premises in 2024, the International Biomedical Institute for Smart Nano Hydrogels, to consolidate as experts in the field of personalized medicines, to continue with the research projects that we are working on, and to launch more products to market. Currently, we have several medical devices and medicines that are close to market, so the idea is to continue working on this. So thank you very much for your attention. And I can ask if you have any question.
Thank you, Olatz. Thank you for your presentation. I would like to ask you about your experience in the Chinese market. If you can tell us a bit about that, or what expectations you have.
As far as I know, our experience with China market, it's with the project, as I have mentioned, Gamma-Regen. We are collaborating with the Taiwan company. We have done almost all tests necessary in order to have the product to be on market. And our experience has been really good. So our idea is to continue working with them, but also we are open to collaborate with other companies, universities, etc.
Okay, you would be interested in doing a similar collaboration or in doing all the tests necessary for that as by the regulators in mainland China?
Yes, we can assume this task. Of course, we have here one department which is focused only on regulatory affairs. So we can assume, as we have said, all the phases of a project. So yes.
Okay. Thank you very much for your presentation and for your participation in the event.
Thank you.
Now our next speaker is Cecilia Garcia from UPM. She will present the work on robotics platform for cognitive and muscular rehabilitation in post-stroke patients. And the floor is yours, Cecilia.
Thank you, Xavi. I'm going to share my screen. Good morning, Spain, and good afternoon, China. Nice to be here. Thank you so much for the invitation. I am a professor at Polytechnic University here in Madrid, and I am also a researcher at Center for Automation of Robotics, a research center that belongs to the UPM University. This presentation is organized in 5 sections. I'm going to talk, as Xavi said before, about medical robots, one of my research line. And I would like to start this presentation with a brief introduction to the problem that we are trying to figure out. A stroke. The stroke is a global problem. About 70 million people suffer a stroke per year, and 85% of the stroke is an ischemic stroke. This the blood flow to the brain is blocked. This rate is going to be increased in the next 10 years over around 24%, and the burden cost in Europe is estimated in 45 billion euro. And in China, we have to say that is the leading cause of death. In the middle and long term, a patient that suffers stroke has serious consequences for the autonomy and the daily life activities, mainly related with the mobility, with vision, but also memory problems, speech problems, and also they experiment personality changes, depressions, and other symptoms. If the patient is lucky, the rehabilitation is start in the hospital between 2 and 5 days after the onset of the disease. And the rehabilitation of the stroke is 1-to-1. What does it mean? That we need one therapy per patient. With this picture, the rehabilitation service has a problem, or they have more staff, or they have technology that help them to deal, to manage this quantity of patients. So in the area of medical robots, I have to say that over the past 15 years, the research in this area has been increased a lot, mainly in surgery robots and rehabilitation robots. And when we talk about medical robot, we don't talk just about the technology itself. We also talk about the protocol. Any medical robot should have a medical protocol associated with it. The main barriers, is my point of view, are the medical regulation, which is very strong in everywhere, and the high cost of research, development, and also the certification that the previous speaker was talking about. Nowadays, this technology is too expensive to think that it could be a global solution for this global problem. So we'll have to work on that. So what we propose, we work in upper and lower limb robotics exoskeleton, and we try to overcome some challenge that this technology has from the technology point of view, but also from the market point of view. So the first point is that we are a multidisciplinary team. We cannot develop medical robot without medical staff. So we start the development of the research and development of the technology with the medical teams, neurologists, physiotherapists, rehabilitation doctors, and psychologists too. And we try to develop robots that be aware about the disease and the symptoms of each particular patient. So this is one of the value proposition, that our technology is model-based. What does it mean? That we personalize the medicine for each patient, okay, and for each stage of the disease. So we around over the past 6 years, we developed a biomechanical model that we include into the control loop, but also this biomechanical model are part of the protocol that we design for the medical staff at clinical setting. For us, this model allows us to test, validate all the improvement that we want to accomplish in the technology, because we can generate the virtual patients, which is the first step to test any improvement that we can to apply in the final prototype. The second challenge that we take into account is the regulation. Regulatory, as I said before, this is a very the regulation is very strong, and because of the experience, we decide to include all the restrictions that the regulation imposed to this kind of devices since the design process. So since the beginning of the process, we take into account the regulatory issues that these technologies should be accomplished at the end of the process. I list some of them, not only regulation related to medical device, but there are machines, so we have to be sure that we accomplish with the machinery regulatory. Of course, that we take all the concept and theory related with robotics into account in the process. I would like to say that here we have ongoing a PhD thesis. She's coming from Mexico. So I would like to mention that because this is an event that links Latin America, Spain, and China. The third challenge that we are working on is in cognitive rehabilitation. We want to link the muscular rehabilitation with the cognitive one. We have also designed with the medical staff specific metrics that will be linked to the technology in order to measure the progress of the cognitive stage of the patients. Now, I'm also working with a PhD student, which is in Colombia, about a game platform in order to get the immersion of the patient into the therapy. So this is another value proposition of the final product. I would like to say also to mention that part of this development was made in a industrial PhD that finished in 2018. The problem of this technology is the cost. The cost associated to the research and development. So I think that we need to decrease cost by including the regulatory issues since the beginning of the process is one of them, but also we need to plan the market strategy since the early stage of the TRL in order to know what the market is going to pay, what the market is prone to pay. So if with this information we don't spend time including some innovation in the technology, that the market is not going to pay that at the end. So I think that the market strategy just should be defined since the beginning of the development, even before the prototyping, because prototyping means cost. And finally, the clinical validation also should be very well planned since the early stage of the TRL, in my opinion. Finally, I would like to mention the market. Medical robots are in the market of professional service robots. These kind of robots against industrial robots are robots that are things to assist human rather than to replace them. So there are huge effort to do in interaction between the robot and the human. But I want to mention that the market is growing with 2 digits. And the market is mainly focusing logistic and inspection and defense robot, and medical robots represent only the 2% of the professional service robot. However, because of the cost of this technology, it represents almost the 30% of the total revenue per year of this market. final conclusion about my presentation, I would like to say that stroke is a global problem with a prevalence that is increasing. To manage the demands, the medical staff will need more staff or technology that help them. Robot could be a good solution if we found the way to decrease the cost, save money, and we have to include also the end user in the loop since the beginning. We need to decrease the cost of prototyping and manufacturing. We cannot decrease the cost of clinical trials, so we have to decrease cost in the research and development stages, even manufacturing. In my opinion, the business strategy used to be planned since the beginning, since the beginning of the technology. And I think that now we are in a good moment. This is a good opportunity for this robot because they're strongly linked with the 5G, IoT, and AI chip markets, and these three markets are growing up. And I think that it could be the advance in this market could be help us to decrease also the cost in medical robots. This is all for my side. So thank you so much for the invitation. And if you want to ask me something, I leave my email also here. Thank you.
Thank you, Cecilia. We have a couple of questions.
Okay.
One is, oops, I don't know what happened. Okay. One is about if the exoskeleton robot is designed to be active or passive training.
We design active exoskeleton, both of them. Upper and lower limb are active exoskeleton. In upper limb, we, as I said before, we are focused on rehabilitation of the stroke. In the lower limb too, but in the lower limb also, we are working in the in the gait assistant in multiple sclerosis patients. This patient has a particularity that is a disease that becomes worse with the time. So the exoskeletons should be designed with enough power to keep the person walking. At the same time, the autonomy of the patient decreases. So we are working in the lower limb. We are working with two strategies.
Okay.
However, I have to be honest. I think that the second one is not. We don't have a business opportunity there.
Okay, so there is a more clear business opportunity with the active one.
Yes. Yes.
Okay. Okay, and there's another question about how do you see the future prospect of exoskeleton robots combined with BCI, brain-computer interface?
I'm working with that. So, in fact, it's one of the metrics that we are working on in order to analyze the functionality of the brain and to try to understand what the brain is. So, this brain signal are. We are trying to decode the brain signal in order to activate the exoskeleton. So this is for me. I think that this is the future, one of the future in this research area. Yes.
Okay, so maybe collaboration with some company or some research institute or university in China around that would be interesting.
Yes. Yes. Sure.
Okay. Okay. Very well. I think all these, the market for this is about to explode, let's say. There
Yes.
is not that much, but it's something that's very promising. Mm-hmm.
Yes, it's a very promising market, and also because of the the AI chips, which will introduce lower consume of energy. So and at the same time, powerful calculation potential in this chip. So I think that there are other markets around the robotics that will help us to grow up.
Okay. Okay. Thank you very much, Cecilia.
You're welcome. A pleasure.
We continue now with our last section in this session, the one that has more speakers, the one about biotech and agri-tech. And we will start with the presentation by Antonio Molina from the Center for Plant Biotechnology and Genomics at UPM, together with INEA and CSIC. And he will talk about biological-based technological solutions, biofertilizers, biostimulants, and biopesticides. So whenever you have it ready, Antonio, you can start.
Can you hear me?
Yeah, everything's
okay.
Fine.
So good morning, everybody, and thanks for the invitation. So as Xavier said, I'm representing here the Plant Biotechnology and Genomics Center of the joint center between the UPM and the National Institute of Agricultural Research, and now integrated in the National Research Council. So we are a joint center. So since our center is quite big, and I will try to give you some general overview of what we are doing to try to give a response to the challenges that we have in the sustainable production of safer food and just to provide enough food for this growing population. So the action that we are just designing just to move in this direction is what we call the program CBGP Sustainable Solutions or CBGP Solutions, and I will introduce to you today briefly. So first, let me just to introduce our center. So and related to our center, just to mention that we are one of the Center of Excellence Severo Ochoa of the Spanish Research System, that you can see here the logo of the center. Now let me check if I can use the laser pointer. Okay, so our center have 4 objectives. Of course, the generation of knowledge and genomics and biotechnology and different tools for functional analysis and genomics. So we have a joint center between the Technical University of Madrid and the CSIC, and accordingly we have educational program. And one of the important things related with this meeting is that one of our strategic objectives is just to develop new product and process relevant for the productive sector, in particular for the agricultural sector. The 39 groups that we are working now at CBGP, so we are around 330 people working today at the center. Are split in 4 research areas: plant development, interaction of the plant with environment, and 2 new areas that we have launched with these grants of excellence of Severo Ochoa: the computational system biology and genomics program and the synthetic biology and bioengineering that was launched on just 1 year ago. So I don't have time to go through all our facilities, but just to mention to you that we have a state-of-the-art facility with fantastic greenhouses, and we will have a automatized phenotypic platform by the end of this year to expand our scientific and technological service. So just to summarize what we are doing here at the CBGP, we are doing science of quality, so publishing about 80 to 100 papers per year in very good journal. Interestingly, 30% of our research activity is financially supported by private company or foundation, like for example, the Bill and Melinda Gates Foundation. And in our DNA, or the CBGP DNA, is this innovation and tech transfer formation. So we have a specific course for all our PhD students. We are very active in promoting entrepreneurship. So actually we have founded for a spin-off company, Plant Response Biotech, that was just sold past December to a Mosaic company, a multinational company in the States, and Genomics for All, Data System, and Agrenbeck. And related with the issue of the presentation, we have several technologies into the market. Particularly, we have developed several agrobiological products that are replacing the chemical-based product like fertilizer or pesticides. And here you see 2 of these products. So what are the challenges that we are facing? So clearly, and this is a challenge not only for us, also for China and the rest of the world, is that we have to use less natural resources, arable lands and water, reduce the chemical inputs, fertilizer and pesticide. This is really urgent to develop sustainable solutions. So just to move from chemical-based solution or synthetic-based solution to biological solution and to develop biostimulant and fertilizer. We need to adapt the crops for production in a scenario of climate change. And to do this, we need to collaborate with the private sector in order to develop all this innovative technology that the agricultural sector are demanding. Just to show you an example of the progress that we have done, I have borrowed this slide from Bayer just to show you the surface that we need to produce one particular amount of grains in corn in 2040, and what we are now doing in 2019, and for the future we need to still to reduce the surface that we use for produce food. But this increase in the production has been associated to the use of fertilizer, and fertilizer are causing serious problem in environmental problem that we have to face. So, and one of the key points is that we have to respond to all these new challenges, like the European Green Deal, and I guess this is a great opportunity because this is a mutual interest between China and Europe to develop jointly a very ambitious program to improve our technology for sustainable agriculture. So how we can do this? So one of the possibilities that we are developing at the CBGP is just to do this in a very open model of collaboration, in an innovative open model. In this model, that is represented in this scheme briefly. So what I want to show you that the challenge that we have are very complex. So we need internal and external collaboration, and this is what it is representing. And also from the Public Research Center, and I will mention in a few minutes that in this direction we have founded the Center of Excellence for Plant and Environment Interaction with two institutes of the Chinese Academy of Science. But also we need the collaboration with companies, with enterprise, and we have in this direction developed a joint innovation unit. Through this process of innovation, sometimes you need to incorporate additional technology and in additional collaboration with a company. And the final output of this is that through this collaboration, we can develop novel technologies in addition to those technologies that, for example, the companies are looking for. And this is our experience with the foundation of the spin-off company Plant Response that we develop novel technologies. So as I said, we are developing now joint innovation units, like the last that we have established previously with Plant Response, and now with the Tradecor company that is from the Rovensa International Group. And through this collaboration, we guess that we can answer this question, because the important thing from our side is that we have to move from lab condition to real condition. And to move from this to here, what we have done is just to develop this, as I told you, this innovative program, the CBGP Sustainable Solution, in order to develop products through our spin-off or through other companies. So briefly, what we are doing in this program that I guess we can just use for our collaboration with China. So we have what we call the CBGP3, or just to enhance the public-private partnership. We have created a Transnational Biology Action Office. We are supporting proof of concept with our Severo Ochoa grants. We are promoting the industrial doctorate with a company. As I said, we have created this Gene Innovation Unit. We are promoting the foundation of spin-off. We are doing the valorization of our technology in early stage. Actually, in the UPN Day, we have a investor day of the CBGP spin-off, and also a presentation of our portfolio by CBGP researcher, and we need the advice of the expert of the field. So in addition to that, as I said, we are very active in internal collaboration, and I'm proud to say and to present here in this forum the Center of Excellence for Plant Environment Interaction that we have founded with the Plant Stress Center and the Institute for Genetics and Developmental Biology of China in Shanghai and Beijing. And this center, you can see the picture of the signature of our memorandum of understanding. Now we are working on the signature of a more global agreement. And interestingly, what we are doing with this through this center is to initiate a novel project. And you see here the 6 projects that we are co-financially supporting in the frame of the pay. So in our case, we are co-financially supporting with the resources of the Severo Ochoa program. This is working very well. Already we had a workshop with this researcher. And then what is next? Next is this collaboration to access to additional reserve funding that we can have from European program, or for example, from the Chineca program of collaboration between CEDETI and Torch or MOST. And actually, I'm proud to say that for the first time, the CBGP is involved in one joint application to the CDTA and MOST with the company Symbor. The Symbor is a company that was born in Murcia, one of the most important areas of production of vegetables and fruits in Europe. And interestingly, Symbor that developed this biostimulant, biofertilizer, biocontrol that are required for sustainable agriculture, has facilities worldwide, but the most important for us is that they have an office in China. They want to expand the technologies, sustainable agricultural technologies to China. And that's the reason, I guess, this kind of initiative is very interesting for the development of and expanding our collaboration in the frame of CEPEI, and also to expand these technologies of sustainable agriculture that our Spanish company, but also the research center like CBGP can contribute to develop in order to fight this or to resolve this challenge that we have of a more sustainable agriculture that clearly is required and needed in China and also here. So, and with this, I will stop, and I will thank you for your time, and I will be delighted to answer any question that you may have. Thank you.
Thank you for your presentation, Antonio. I think it's very impressive the work that you do and how you have organized all these technology transfer issues in your center. And I would like for you to give any recommendation, if you have in your experience of collaborating with Chinese partners. If you know of other researchers, what would you recommend them for doing this successful collaboration?
Well, this is a great question. This is the question. So I'm participating in the European Union KINOC group that is discussing the collaboration with China. I have been involved in this group for almost 1.5 years. And I guess the key point from this for the CEPEI success is that this is a bottom-up approach. So basically what we have done is to identify the research group in the Chinese Academy of Science and the research center that we would like to collaborate with. We have contacted them, they have contacted their institute, and they agree to establish this collaboration, and that's the reason this is working very well. So because at the end, the managing and the objectives of this initiative is just based on collaboration between scientists. And after that, we will see the next step, because clearly during the visit of the president of the Chinese Academy of Science in Spain just 2 years ago, and he was also visiting the CBGP. So what they like this model, but they were putting some pressure that they want from this collaboration to have innovation. And this is what we are trying to do now, just bringing this company Symbor, but there are other companies that we are collaborating that they will be delighted to expand the commercial network. Particularly, this is important for the Spanish embassy, because one of the key points is that Spain has a great potential, a lot of small and medium enterprise that are leader in sustainable solution for agriculture. And I guess that the Asia and particularly the China market is impressive, and we should be aware that there are a lot of opportunities. But just coming back to your question, the trust between a researcher that want to collaborate to do research, and you can build this from the bottom.
Okay. Thank you very much, Antonio. Very enlightening, your answer. And let's hope that these collaborations in the field of innovation real do happen.
We hope so. Thank you.
Okay, so we move now to our next presentation by Luz Karime Atencia Pallares. She will present her work on remote sensing technologies to optimize the use of water irrigation in agriculture in the company UTY, and at the same time it's PhD research done at UPM, right, Luz?
Exactly. Yes, exactly. I'm an industrial doctorate student, and now I'm working with the Managed Technical Works, is the name of our company, and Polytechnical and the University of the Polytechnical Madrid, together with the financial supported by the Comunidad de Madrid. So I will share my screen. You can see my screen.
Yeah, we should start presenting because we see the PowerPoint.
Okay.
Okay.
Now I would like to start with a short introduction about the remote sensing. Okay, the remote sensing technologies is in agricultural production is an increasing trend over the past 20 years, especially the use of unmanned aerial vehicles. They represent one of the most advanced platforms for the remote sensing applications. In agricultural production, the water availability is a crucial factor, mainly in a climate change situation that we are. For this work, we focus on my work is focused especially in the wood crops. And this year, for example, we work in the vines. That is a high value crops in Spain. Our company, the company, we are a multidisciplinary team. We work in civil engineering, agronomists, and physicists. We use the UAVs, the unmanned aerial vehicles, to provide valuable services in different product sectors. But now we are focusing in precision farming, in particular. Our team. This is our team, and I would like to talk about the agricultural engineering, Roberto and me, that we had the experience in China, for example, 5 years ago, with an internship with the Universidad Politécnica de Madrid, and we work with the olive growing in Mianyang, and was a very special experience, and we learned a lot about that crop development in China. So go back to about our work. We working in precision farming, and we want to get the following objective about the reduction of resources, reduction of machine and work hours, improving the crop yield and crop quality, minimization of environmental impact using the different resources, especially the drones and the satellites. The precision farming has a lot of many management different agricultural practices, but I would like to talk more about our work now. We focus on especially in the watering recommendations. To get the recommendation, we use information about the different sensors, thermal and multispectral sensors, using we can see these maps for multispectral imaging from the Binajar. And with that information, combine it with the satellite information, we try to get the watering recommendation, but we had some problems, no, because no company that they using only satellite resources or WAPS resources has some problems, but we find the solution, combine that resources. How? The satellite has a very great, high temporal resolution, but a low spatial resolution, about 10 meters. So for woody crops, it's difficult to get a very clear information. So we combine that information with the more specified information from the drones that has a very high resolution, but less temporal resolution. So we combine both and the information from the meteorological sensors and artificial intelligence and algorithms to do that watering recommendations. For example, in this slide, we can see in the left part the information about the satellites, and if we can see the special influence of the soil that have changed the information, so we get better information, combine it with the drones. We can see for example, this is the evapotranspiration maps, so we can get a better resolution using that combination, and we see in the right part, in the right imagine, how this is more clear, no? The different tree. This case, for example, is the olive grove. So, what is the principal support? The principal technology that has or company has this the crop sense technology. The crop sense technology provide use a neural network to predict watering needs with high level precision, and we give this information to the customers through a digital platform, a easy digital platform for the customers that they can see. In this slide, we can see the short little picture about our platform. If you want to visit the platform or page, you can click this slide or visit our website and check all the different information, because we have the possibility to get the information about the satellites just, or drones, or both. With using not only water recommendation, multispectral information about the vegetal index, and the farmer have all the information in the same platform. And now I want to talk about or possibility to work in the other countries. This platform is available to use in Spain, in Portugal, and Morocco, but it fits to other countries, and we work in that connection with other farm or other agriculture producers in the other countries, and we hope to grow up about that. And that is it's this overview about our work, and thank you so much. And if somebody has a question.
Okay, thank you, Luz, for your presentation. I wanted to ask you which kind of crops your solution is good for. You said you had experience in China with the olive production. Does this solution that you have presented is good for olive, or which other kind of crops you think it would be useful?
It's a special, we make it special for the woody crops. So we have a lot of that, a very extended database about the olive. We work a lot in olive here in Spain, and in vineyards and pistachio, because this technology is good for monitoring when the crops is not completely full the soil, you know, because we can separate the soil and the vegetable part. So it's important has this technology for separate that, because maybe we can get confused information. So, but we can use the satellite, for example, only with the corn or that kind of crops. But for woody crops, this is a very interesting technology and works very well.
Okay, thank you very much, Luz. And now we move to our last presenter of the day. Is Alejandro Casas from the company Kimitech, and he will present what they do in biochain development and validation of bioproducts for the green production of agricultural crops in China and Spain. So the floor is yours, Alejandro.
Oh, thank you. Thank you very much, Javier. Let me share my screen. Thank you very much for the invitation. And I would like to introduce a little bit about our company first, and then talk about the Biochain project that we are ongoing in Chinese markets. So our company, Kimitech, was established in 2007 with a clear vision that we believe in a different way of producing food by doing in a natural and sustainable way. So the aim of the company is to develop natural solutions, and I'm going to explain how to do that, but with the same efficacy than the chemical products that are already existing in the market, not only focusing the biopesticides and the biocontrol, but also in the biostimulant side. So this is in response to all the global challenge of sustainable agriculture that is already on the table in every country, right? So we have to take three main points. In our vision is the productivity of the grower. So all the solutions, natural solutions that they will be using have to be economically sustainable for them and have no impact in the environment and in the human health, right? So this is a little bit of the history of the company. I'm not going to stop in this, but just to have an idea, this is a 15 years company, was set up in 2007 for owners. And in 2014, we started a lot with all the research program and projects, and we obtained our first Horizon 2020 for the biocontrol in Europe. Then in 2007, we developed two biopesticides coming from this project. And in 2019, we opened our Mavi Innovation Center. And this is the biggest R&D center in Europe for natural components. I'm going to explain you a little bit more in detail. And we implemented also the artificial intelligence platform applied to all these natural components that we already set up in a few months ago, right? And in our vision in the future is to grow our knowledge in natural components and to apply all this technology not only in agriculture and also jump into other sectors as agriculture, livestock, and human health. I said before, Mavi Innovation Center right now is the biggest and the largest research center of natural components for the development of biopesticides, probiotics, and biostimulant in Europe. Just to give you some numbers, it's more than 10,000 square meters. Half of them is the research facilities, and other is for testing the products and validation, let's say. We are more than, it is 60 full-time researchers. Right now is more than 70 people just working in the R&D department. So that means it represents like a 25% of our company. This is quite a lot. And we have more than 50 open projects already. As I mentioned before, working in biostimulation, plant protection, and soil health. So it's quite a lot. And already the company has more 4 Horizon 2020 from the beginning, right? Apart from this R&D, this is our, for me, this is our core. We have an international presence in more than 90 different countries all over the world. So that means that we have a good knowledge of any kind of crops and conditions, and even the technology. 4 subsidiaries, one of them is in China. So that's why we implement all these projects, but also we have in the United States and Brazil and Latin America, and more than 12 commercial offices in other countries. So our knowledge of the products, technology, and what is happening in the world is quite big. And that's why we're so adaptable in any kind of conditions. Those are the 4 Horizon 2020 that I mentioned before. And in total, the company, we get more than 23 million euros in research projects from the beginning. The first one was in 2012 till now is more than 23 million euros. Apart from the financial projects, we have our own pipeline of products of research with more than 50. With all of them, we develop natural and effective solutions. So that's the keywords. Have to be natural, but have to be as effective as the chemical ones. We are doing that. Working with the plants, with the botanical extracts, extractions, fermentations, pyrolysis, macerations, and other processes, with microbiology and with microalgae mainly. And we are making synergies in combination between all these 3 technologies in order to obtain this level of efficacy. But at the end, it's developing of biostimulant, biopesticides, pre and probiotics, and also we have a seed treatment unit, because also is, I mean, we feel a demand in the industrial seed treatment. As I mentioned, artificial intelligence, we put this technology into our research process in the last year in order to speed up all the research process and to let's say work with all the existing knowledge worldwide. We are also 360 open innovation, so that means that we are in cooperation with universities, research centers, and other companies worldwide. Our vision is our brand, so we want to bring all this technology to the world. So that's why we need to cooperate with companies worldwide. So the Biochain Project, this is a project that we start running in China in the last year. This is the aim: development and validation of natural products for the green production of horticulture crops in China, also in Spain, but the main one is in China. And there's 3 main players in this project. One of them is Skimitech, the Mavi Innovation Center that we explained before. Then is Uno, is one of the largest vegetable producers in China, with around 2,000 hectares of lettuce, tomato, cucumber, cabbage, and other vegetables. And BAAFS, so there's Beijing Academy of Agriculture and Forestry Science, that is specialized in plant nutrition, soil, and crop. So what is the issue? I mean, why we start this project? We also mentioned in the previous conference. So this is the green lane, the farm to fork, the restriction of the supermarket. So both China and the United States, and the European Union also needs to reduce the use of chemical pesticides and also the chemical fertilizers. So this is This is not more a trend, this is a reality. And the traditional use of chemical products leave a lot of residual footprints in soil, crops, and environment and human health. So we need to replace with a natural solution. So that is the main objective. First of all, we need to understand specifically what are the main needs in China, because every country have different conditions and different demands. So it's understanding the needs and then according to the needs to develop innovative solutions adapted to these Chinese conditions on market. This is one of the largest markets in the world, and we need to, it's not copy and paste. We need to understand what is happening there, what is the main concerns, what is the main challenge they have, and based on that, develop the right and specific solution for that. This project aims to develop 3 natural sustainable solutions. This is the main scope. Maybe it could be more than 3. But the aim is these 3 natural, sustainable natural solutions with the same level of efficacy than the chemical ones, with a non-negative impact for the environment and human health. So these 3 solutions will be 1 biopesticides in order to, with the objective to control the main pest and diseases there, and also prebiotics and biostimulants, because we need to enhance the potential of the crop and the quality and yield. This project is three different parts. The UNOM will define the agronomic challenge. So they are the big producers, the growers. So he knows exactly what they need to improve. So they will define the agronomic challenge and leave the activities related to determine the crop, soil needs, and etc., stress, and any other conditions that we have to take into consideration. Our MAVI Innovation Center, we will be, according to this challenge, we will develop specific products to cover these needs. And the university will lead all the field evaluation together with UNOM. And also we will help us in all the things that all the previous experience that they have in the knowledge of the Chinese agriculture practice. The result is that we will have a biostimulant product, we can say as an alternative to the synthetic hormones. We will have a probiotic, functional microorganisms, according to the microbiome of the Chinese soils and this crop, and a biopesticides with the same efficacy as the chemical products in order to reduce the impact of the chemical and the residues in the final fruit. So to end, what are the main advantage, what we expect in this project? First of all, is to manage the crop resistant to chemical pesticides. The use of biopesticide that we will be developed under this project will increase the yields and quality, and will be implemented in the IPM programs and organic farming also. The use of the residue of the fruits. This is one of the main concerns that we mentioned before because of the farm to fork and the supermarket restrictions. Soil health is understanding the microbiome of the soil and developing specific solutions to enhance with the prebiotics and promote beneficial microorganisms that are existing in the soil, and with the aim of helping in the nutrient uptaking, water management, and also the reducing of the use of chemical fertilizers. Of course, with the biostimulation and plant nutrition program, with the food quality and productivity, we will be applying a specific biostimulant that helps to increase not only the yield, the productivity, it's also the quality, which is really, really important. And this is one of the factors that also this kind of company is looking for the differentiation. And of course, all of this that we mentioned before, it's aligned with all these strategies for the sustainable agriculture. So we will help all the Chinese market to be more sustainable. So thank you so much for your time.
Thank you. Thank you for your presentation. I would like to ask you, since you are in charge of international development, you're a CEO for international development at Kimitech, if you have anything that you can tell us of how this project in China has been different, or of what you have found that you weren't expecting, or what would you recommend to someone doing some similar project in China?
So yes, as I mentioned before, we already develop and sell products in 90 different countries. So China for us was and is a big challenge, because it's the biggest market in the world, and the level of the technology and the use of the chemical fertilizers and pesticides is so high. And so one of the main challenges for us is to understand exactly what are the main demands and needs and the challenges of China. So that's why we need to have some local partners, the university part and the research part, and also the farming, because they're already so for us, this project helped us to have a clear understanding of what is the real situation. I mentioned before, it's not just to I developed a product for Europe and then sent to China and try if it works there or not. So it's more to understanding the real needs, the real demand, and the real challenge of the soil and the growers, and what are their expectations, and based on that, create and develop the products with all this knowledge.
Okay, thank you. There is a hand reason. Okay.
It's me, Antonio Molina. Can I ask directly?
Yeah, Antonio. Of course.
Hi, Alejandro. How are you doing?
Fine, Antonio.
So my question is related with your last comment. So what is your position regarding this registration of the product in China for commercialization? How do you know about, and in the case that you are developing product based on microorganism, have you any idea how to fulfill the Nagoya protocol? Because this is a serious problem regarding the commercialization of a product based on microorganism.
Exactly, Antonio, and this is a good question. We already have, we have in the commercial stage in China, so we already sell some of our products in China. So we know other, let's say, registration process, but all of them is more in the biostimulant side. Okay. And you're right, Chinese market is really restricted to microorganisms, and even for the biopesticides, you have to, let's say, comply with all the requirements in China. They don't accept anything that you do in the United States or even in Europe. So that's a big challenge. And I'm not going to be able, as far as I know, I'm not going to be able to register a product from Spain. So the main purpose of this microbial part, let's say, was a demand of this Biochain Project. So they wanted to understand and they wanted to, let's say, develop microorganisms or a co-inoculant according to the conditions and so on. So the second part of the registration, maybe it's going to be not with our company, with Comité. We will do all this development process and so on, and then we have to see how we can do that or not, or through a local company in China. Maybe we're not going to be able to do it by ourselves here from Spain, but that will be the second part. But you are right. I mean, it's microbials, and mainly in China, is one of the most difficult situations.
Okay, thank you very much.
Okay, thank you. China poses quite a lot of challenges, and I think that in this field is even a bit more than in other fields. But there are a lot of opportunities, as you mentioned. I think there is a lot of interest from the Chinese part, both from producers and from the government. So thank you very much, Alejandro, for your presentation. So this is the end of the session. Let me tell all of you that from Universidad Politécnica de Madrid, we will be opening in the second half of this year a Center for Innovation in Nanjing that can be helpful to any research center or company that wants to do some technology transfer, some innovation with Chinese partners, and we'll be very, very, very glad to see for possible ways of collaboration. We have the support of the Nanjing local government, and we can offer some support for companies wanting to do something with local companies. And for the topics that we have covered today, for sustainability, for health, and also for biotech and agri-tech, all of these topics are topics that are very interesting for an ICT, for the local industry, and in particular for the Nanjing the development and technological zone that is supporting this new center. Okay, so we will be very glad to keep in contact, and if anyone wants to get more information from any of the speakers, you can contact me, and I will forward it to them, or I will send you their email addresses. Okay, no problem about that. Thank you very much to all the speakers for your presence here, and let's hope that there will be more interactions and more technology transfer projects in the future with China.